So, as you remember, we were kind of in between two different areas. That area was along the boundary of the north was kind of our initial target. We kind of strayed from that because of the observations. So, one of the main things that told us we kind of maybe need to move away from the boundary reading was the satellite. So this is the archived satellite data for yesterday. Starting in the late morning, so this was all that elevated convection that we were monitoring through the day. We wanted that to move out, get some destabilization behind it. And eventually it did. And so as we go through, you see it moves off. And then by about mid-afternoon or so, 3 p.m. or so, you start to see some bubbling here. Lots of bubbling cumulus along the dry line back here in the west. Even some up here to the north, closer to that boundary. But the thing that we were seeing as storms were initiating was notice all this stratus cloud cover. It's not really this bubbly cumulus like you see down along the dry line. That bubbly cumulus is indicative of more cumulus that are developing through daytime heating. As the ground heats, those air parcels of the surface will rise, and that's how you get surface-based storm development. These ones up in here, all this stratus cloud cover and a lot of these horizontal convector holes we were talking about that develop, that indicates stability, and that tends to indicate that any storms that go up in that regime tend to maybe elevated. So you saw some storms kind of emanate from that area of stratus and horizontal convector holes. So we thought those storms were initiating in an elevated sense, in that kind of more stable atmosphere. Also, up north, our dew points were in the 40s, upper 40s. For some reason, the moisture had not made its way up north to the boundary like models were showing it would. I have a hunch it was this morning convection. So that morning convection lingered a little bit into the afternoon. It didn't allow those mid-50s dew points to quite get up to the boundary like they did kind of down along the dry line areas to the south. So those were two of the reasons why we thought, the northern clay might not be the best clay. Now those did evolve into supercells, and those were fairly robust up there, but ours kind of developed along the dry lines and sort of a triple point with perhaps some very diffuse remnant outflow from that morning convection. And it's a little bit hard to tell, but if you watch the path of that morning convection, it just tracks right there along I-70. So you have some cooler air where that went through. Going into mid-afternoon, as those storms were starting to bubble along the dry line, you had temperatures in the upper 70s up here with dew points in the mid-50s or so. Temperatures in the low 80s down here with dew points closer to around 50. So you had a little bit warmer temperatures away from where that early convection developed and moved through. And you also had a little bit more meager moisture. The boundary layer was a little bit better mixed. So again, vertical mixing is when you have strong surface heating. You get air to rise at the surface, but there's also an equal transport of air down to the surface, down toward the surface from above. And you have slightly drier air aloft like we had yesterday. That drier air can go down to the surface and somewhat mix out the dew points. The dew points can decrease ever so slightly in the afternoon. So you had a little bit better mixed environment down here. And then you have this sort of remnant outflow. You see the cumulus all pretty prevalent down to the south with no real cumulus to the north. So there's some sort of boundary there. And that kind of matches with where that differential heating boundary was. It was pretty subtle. This was not a very big complex of storms at all, but it was slightly elevated and enough to produce maybe some gusty winds at the surface and at least cool down the environment where it tracked through. So you got a little bit of a boundary there, an outflow boundary, leading up to the dry line. So the dry line was back in here. Dew points in the low to mid 40s to the west, 50s off to the east. And so there was a little bit of a moisture gradient here. It was a subtle dry line, not your typical plains dry line that you'll see, in some of the upcoming days. But it was enough of a moisture gradient to be considered a dry line. So you had your dry line up here, outflow boundary up here. So that's our storm kind of developed right on that triple point where the outflow boundary intersected the dry line. We also had development down to the south along the dry line as well. That was in an increasingly more mixed environment. You see 84 over 50, 85 over 45 down here. So moisture decreased and temperatures increased with southwest extent along the dry line. That's where our storm went up. It was kind of in that sweet spot. Slightly cooler temperatures, slightly higher moisture. And so we felt that was going to be the best storm of the day, and that ended up being the best storm of the day. Again, those storms to the north did evolve into supercells, but they got messy very quickly. The storms went up. There was quite a bit of development in that, what we think is an elevated sense. They may have become surface-based later. But eventually the cold front did start sagging to the south as well. That was another concern that we had. The cold front was expected to sag a little bit to the south. So with an eastward storm motion, a southward sagging boundary, those storms were going to have a tendency to be undercut and elevated with time, whereas our storm had a little bit more breadth from the actual cold front, and so we had a feeling it would be more discrete, longer, and more surface-based, longer. And so it developed. The storms down along the dry line kind of sputter, and ours kind of developed into a real robust storm, and kind of that sweet spot on the triple point. So that was kind of our thinking there going into the afternoon. Especially, you can see it visually as well. That's something you want to look for a lot when you're out chasing in your target area. Just look at the sky, use your eyes. You saw a very stable looking cloud cover above us, very flat, laminar, sort of not really convective in nature, any of those clouds that moved over us in Concordia. Whereas to the south, you saw more bubbly cumulus, especially as we started to get closer to the dry line storm. You saw a lot more bubbly cumulus with vertical development. That's a much better sign. So that was kind of our thinking through the afternoon yesterday. So as far as how the storms sort of evolved, again, forcing was very weak. So you had just enough forcing on the triple point to give us that discrete storm there. But overall, forcing was weak. You're a little bit closer up here to the forcing, but with those temperature dew point spreads pretty high, dew points only in the 40s, those likely, you had a lot of updrafts going up at once in sort of that elevated sense, in sort of a popcorn type fashion, and so they all went up, started producing a lot of outflow, and it kind of congealed into a complex more than a discrete supercell. Whereas ours was kind of just one storm by itself. So you got those initial dry line storms there in the better mixed environment. Likely the convective temperature was breached, so temperatures got warm enough at the surface to allow parcels to rise on their own. A little bit of extra forcing area, and you see right away those storms kind of congealed into a clustered mode, which was not all that favorable for good chasing, whereas ours was kind of remained discrete, just that one updraft. And then eventually it started turning pretty hard to the right, and so that was an interesting evolution of how that played out. So if we go to our high res radar here from Hastings, so there was our storm. Concordia is up in here, so that's where we started our chase. Basically, that was our staging point, and then this was our storm down in here. So I'm going to go forward a little bit in time to kind of discuss what went on in that period when it was that kind of high base storm, that hailer that was getting going, that we were following to that real robust right turning supercell. So just gonna let it load here. I'm gonna put it on the single. So we did have multiple updrafts that went up at once. As you saw, we kind of had that initial updraft to the north near Tipton, that was the main one, and then eventually that southern one developed. That's a fairly normal process for that to happen. You can get multiple updrafts going up at once, and then they'll interact, and then one will take over as the interaction happens. So that southern one started to become more and more robust, but it was moving off to the kind of east-northeast. So it wasn't really robust yet. And then you kind of started to see this split happen. So you see this cell down here, and then this one here, kind of a left split and a right split. This is fairly typical early on in the storm life cycle, especially when there are straight photographs. When your photographs are very straight line, that tends to favor more splitting supercell. So you get that right split and a left split. So the updraft will split into a right mover and a left mover. The left mover tends to be more of a hail producer. Very seldom does it produce tornadoes. The right mover tends to start turning hard to the right of its previous path, to the right of the mean flow. And that's what ours did. And so it started to sort of dive to the south, had additional updrafts going up on the flank of the storm. And so the updraft kind of just continued to propagate farther and farther southeast as those updrafts went up and kind of took over time. And that's what helped this become a very, very robust supercell. Of course, as we talked about, temperature dew point spreads were high, so the tornado threat was always going to be kind of low. But we still were able to get a real robust right-moving supercell out there because of those storm dynamics. So you always want to watch for that when you're out there. And of course, as we saw, the photographs were fairly large and looped, especially by early evening. And I assume by this point they were somewhat looped as well. But they may have been initially on the straighter side, which happened to induce that split, or the storm was somewhat elevated initially. So you have your large looped photograph, you draw it on here, an example here. So if you have your large looping photograph, let's say the storm is elevated. So this would be the lowest couple of kilometers of the photograph. If the storm is elevated above that, you basically are not looking at any of that lower portion of the photograph. So what you're left with is effectively a straight photograph. So that can give you splitting storms when you have a large loop photograph. I did take a peek at the Topeka vertical wind profiler as the storms were kind of initiating. It was somewhat straighter than what we saw later in the evening, so I think it was more so our storm was surface-based. But that straight line photograph initially allowed the storm to split, and then as the low-level jet ramped up, that right mover was able to kind of take over and become our show. So that is kind of the deal for yesterday. Any questions on yesterday and how things played out?
The first question is on the, you showed us the satellite and the radar, and it had the station plots on it, and it was an R-type product. Where did you get that?
College of DuPage. So it's the weather and satellite